Hello students. We shall start with the logarithm again. Continue with the logarithm today. So we define logarithm y is equal to ax. A raised to x implies that log y to the base a is equal to x. A is a number. A, the base, is a number. Is a number. It's a greater than 0. A is not equal to 0. That we have seen yesterday. Why a should be greater than 0? We have seen a should be equal to 1. That we have seen. Now see, logarithm is always log y to the base a is equal to x. When we write a number in index form, index become logarithm. Now y should be always positive. Should be always positive. Y should be always positive. Why? Because y is equal to a raised to x. A is a real number greater than 0. Real number greater than 0. A is greater than 0. So a raised to x is always positive. Always positive. Therefore, logarithm exists only for positive number. Again, I'll tell you, y is equal to a raised to x. Y is greater than 0. Y is not equal to 1. So a raised to x is always positive. Hence, logarithm exists only for, remember it, logarithm exists only for negative positive number. Now, properties of logarithm. Properties. We shall learn properties of logarithm. So listen, a is equal to a raised to 1. So how do you write logarithm? This is your power or exponent. This is the base. This is a number of argument. So log a to the base a is equal to 1. So first property we learned. First property is that logarithm of any number to the same base is 1. Repeat it. Logarithm of any number, logarithm of any number to the same base is 1. You got it? Logarithm of any number to the same base is 1. This has application in physics, chemistry, maths and everywhere. So remember it. Second property is that we know how do we define 0. A raised to 0 is equal to 1. That's 1 is equal to a raised to 0. Where a is the base here, 0 is the power here, index here, 1 is the number here. Logarithm of 1 to the base a is equal to 0. The second property. See, logarithm of any number, logarithm of 1 to any base. See, logarithm of 1 to any base is 0. Remember it. A is any number. Any number. This is the second property. Logarithm of 1 to any base is 0. Third one, I'll give an example to you. Third property will take with an example. Say, look here, 8 is equal to 2 raised to 3. All of us know it. 8 is equal to 2 raised to 3. Or any number you can take. So logarithm of 8 to the base 2 is equal to 3. This is 1, this is 2. Instead of 3, you put log 8 to the base 2 here. Log 8 is equal to 2 raised to log 8 to the base 2. See what happened? Here we put this thing. So we got 8 is equal to 2 log 8 to the base 2. So if I write generally, a is equal to e log a to the base e. This is both number will be same, remember it, or f of x is equal to e log f of x to the base e. This is a very important relation in maths. Various places will be using it. Next point is this third property. Next property is log product rule. What is product rule? Logarithm of x into y to the base a is equal to log x plus log y to the base a. Now we'll prove this property. It's very important. What does this multiplication become? Multiplication become addition. This property will prove. Let m is equal to log x to the base a. So what is your argument is x. So what will you get? X is equal to a raised to m. And let y is equal to n is equal to log y to the base a. Therefore y is equal to a raised to n. This is the first one, this second one. So now what is xy? Xy is equal to a raised to m into a raised to n. Xy is equal to a raised to m plus n. I hope you got it. Logarithm of xy into a is equal to log x to the base a plus log y to the base a. What we assumed here, m is equal to log x to the base a, n is equal to log y to the base a. Therefore, by definition of logarithm, x is equal to a raised to m, y is equal to a raised to n. It is n, not x. Be careful about my x. Therefore, x into y is equal to a raised to m into a raised to n. Xy is equal to a raised to m into n plus n. Now, this is actually what is it? This is a number. This is base. Be careful about my spelling also. This is your power or exponent. By definition, what will happen? Logarithm of x into y to the base a is equal to m plus n. Logarithm of x into y to the base a is equal to m plus n. What is m here? M is nothing but, see, m is nothing but log x to the base a. N is nothing but log y to the base a. Y to the base a. So this is an important relation. You will use in chemistry, physics, maths, everywhere this kind of relation. So learn it properly. Logarithm of xy to the base a is equal to logarithm of x to the base a plus logarithm of y to the base a. Next one is, we'll extend this rule. Product rule is extend. Suppose logarithm of x, y and z base to a. Logarithm of x into y into z to the base a is nothing but logarithm of x to the base a plus logarithm of y to the base a, logarithm of z to the base a. This is, I hope you got it. Next property is division property. I hope you got it. If you have doubt, you can post to us. Logarithm of x by y to the base a is equal to logarithm of x minus logarithm of y to the base a. Logarithm of x divided by y to the base a is equal to logarithm of x to the base a minus logarithm of y to the base a. Here also we can apply same rule. Method 1 we will do now. Let log x to the base a is equal to m. That is, how do you write down? How do you write it? It goes like this: x is equal to a raised to m, and logarithm of y to the base a is equal to n. How do you do this one? Y is equal to a raised to n. So log x to the base a is equal to m is equal to x is equal to a raised to m. Log y to the base a is equal to n is equal to y is equal to a raised to n. Therefore, x by y is equal to a raised to m upon a raised to n is equal to a raised to m minus n. So x by is nothing but a raised to m minus n. This is your index. This is the exponent here. This is a base. This is a number. Therefore, logarithm of x to the base x by y to the base a is equal to log m minus n. Substitute the value of x raised to m and these values is equal to log x to the base a minus log y to the base a. I hope you got it. It's very simple relations. Next one is next relation, product rule. How will you do this one? I hope you got this logarithm. Next one is power rule. Power rule. What we have seen now, no? Product become product. That is, product becomes sum. Division become subtraction. Subtraction. Now power become multiplication. What we saw, product becomes sum, division become subtraction, power become multiplication. So k log b to the base a is equal to log a b raised to k. Right? So how do you write? K belongs to R. K is belongs to R. How do you prove it? Multiplication, power became multiplication. So we will prove this one. Let log b to the base a is equal to c. B is equal to, tell me, log b to the base a is equal to c. B is equal to a raised to c. Now, what is b raised to k? B raised to k is equal to a raised to c the whole raised to k. A raised to c k. Now, take logarithm of log b raised to k to the base a is equal to ck. But what is c? C is this much. K into logarithm of b to the base a. Could you get it? Should I explain this once more? Listen here. K log b raised to a is equal to log b raised to k to the base a. Or you can write this one. Here from RHS we take RHS. Let b log b to the base a is equal to c. So b is equal to a raised to c. It's very clear to you, I hope. Log b to the base a is equal to c. B is equal to a raised to c. B raised to k is nothing but a raised to c the whole raised to k. You know it, a raised to c k. Then b raised to k is equal to a raised to c k. Logarithm of b raised to k to the base a is equal to ck by definition of logarithm. Do you see what is this one? What is c? Logarithm of b raised to k into a is equal to k into c value. We'll put it from here. k into logarithm of b to the base a. So these proofs are important in the sense that you learn the skill in maths. That's all the importance for it. Logarithm of b raised to k to the base c is equal to k logarithm of b to the base c. We are a. Sorry, it's a. Power became multiplication. So you see, what is log 7 square base 2 is equal to 2 log 7 to the base 2. Remember it? Log 7 square base 2 is equal to 2 log 7 to the base 2. Now it is not log 7 base 2 into log 7 base 2. Remember it. Next one is very important section. Base changing rule. We call base changing rule. Shall we do one example? See, look here. Application of this side will show you. See, what is k log a to the base b is equal to log a to the base a raised to k b. Now we will apply this rule to prove the previous one. Logarithm of x to the base a, x by y, a to the base a is equal to log x to the base a minus log y to the base b. Take the RHS. Just take the RHS. What is here? Look at here. This point here you look. Logarithm of x to the base a plus minus 1 logarithm of y to the base b. Your k is minus 1 here. Your k is minus 1. So what will happen? This become, what will become of it? Logarithm of a to y raised to minus 1. This minus 1 came here, y raised to minus 1. Base is a. Logarithm of x to the base a into logarithm of into y raised to minus 1. So logarithm of x by y to the base a. This came down this way also. Right? Now next property we will learn. After that we will do some sums if possible today. Otherwise sums will be done next class. Advanced sums will be taught. We will do advanced sums after completing trigonometry. Say base changing theorem. This is used in calculus many places. This base changing theorem is very easy. Logarithm of a to the base b is equal to logarithm of a to the base c divided by logarithm of b to the base c. So how will you do this one? This is a rule. You do one thing here. You put this one. That logarithm of a to the base b is equal to k. Just let logarithm of a to base b is equal to k. Then how, by definition, what will you get? Tell me. Tell me by definition what will you get? A is equal to b raised to k. A is equal to b raised to k. From definition. That is, from definition we got it. Now, here is the base is b, number is a. Here base, both base c only. Now we take log to the base c. Therefore, logarithm of a to the base c is equal to logarithm of b raised to k to the base c. Is it clear to you? Logarithm of b to the base b raised to k to the base c. Logarithm of a is equal to logarithm of a to the base c is equal to logarithm of b to the base b raised to k to the base c. Therefore, here what will happen? Logarithm of a to the base c logarithm of a to the base c is equal to k into logarithm of b to the base c. Now what is this k? K into logarithm of b to the base c is equal to logarithm of a to the base c. What is k? K is this one. Logarithm of a to the base b into logarithm of b to the base c is equal to logarithm of a to the base c. So logarithm of a to the base b is equal to logarithm of a to the base c divided by logarithm of b to the base c. I hope you got it. Should I explain once more? Now we will prove another important property used in calculus and etc. Important. Be careful of my English. Important property. Okay. See, logarithm of a to the base b is equal to logarithm of a to the base a base into a and logarithm of b to the base a. Now logarithm of any number the same base is equal to 1. Look here what I did. Logarithm of a to the base b. I changed base both side a. Logarithm of a to the base b is equal to logarithm of a to the base a divided by logarithm of b to the base a. Now what is it? It is equal to 1. So what will happen? Logarithm of a to the base b is equal to 1 by logarithm of b to the base a. Remember it. Very important. Logarithm of a to the base b into logarithm of b to the base a is equal to 1. This applied many times. This is inverse relation. Logarithm of x to the base y. Listen boys. Listen students. X to the base y is equal to logarithm of 1 by log of y to the base x. Right? One more rule. Supplementary rules. And you see, we have learned one rule. What is the rule is? Logarithm of x to the base a raised to m is equal to m into logarithm of x to the base a. Now we will find out what will happen. Logarithm of x to the base x raised to m to the base x, logarithm of x a to the base a to a raised n, base is a raised n. Logarithm of x to the base a raised n. What will happen is, see, logarithm of x to the base a by logarithm of a raised n to the base a. Remember, look at here how I wrote. Listen, logarithm of x to the base a. Next is logarithm of a raised n to the base a. Both sides took logarithm based on a. This is a, this is also a. Now you see, apply power rule here. Logarithm of x to the base a into divided by n into logarithm of a to the base a. Right? So what is logarithm of a to the base a is equal to 1. We have seen it. So logarithm of x to the base a by n. Suppose what you have learned now, logarithm of x to the base x to a raised to n is equal to 1 by n logarithm of x to the base a. Logarithm of x to the base a raised to n is equal to 1 by n log of x to the base a. Now see what is here. Power of x, that is power of argument, become multiplied. Power of base get divided. Power of argument get multiplied. Power of base get divided. Therefore, Combine this formula. Logarithm of x to the base n to the base x raised to n to the base a is equal to m into log of x to the base a. This first one. Second one, logarithm of x to the base a raised to n is equal to 1 by n logarithm of x to the base a. Combine these two. What we can write is logarithm of x to the base m a raised to n is equal to m by n logarithm of x to the base a. I hope you followed it. We shall go with problems next class and one or two more properties. That property I am going to teach is b log a to the base c is equal to a log b to the base c. This exchanging b and a can be exchanged. This property we will learn next class. Thank you, students.